Hello everyone. In this video we are going to do edge avoider using ultrasound sensor. Now what is edge avoider? You have kept the robot on a elevated platform. It is traveling on the platform. When it reaches the edge of the platform, it doesn't fall down. It detects that there is an edge and it takes a corrective action, that is it may turn and start moving other side. It is edge avoider using ultrasound sensor. We are going to modify this program and we will understand while modifying that we have to do very small changes to achieve the functionality we want to achieve. We have a vehicle, so we will have Fire motor library. We create instance, so that doesn't change. Also, we are going to read the ultrasound sensor value, the distance value, so we need a variable to store it. This also doesn't change. In sensor program, we read and we store. So even this doesn't change. This is same, read, store. Now it comes compare. Now here we need to start thinking. The sensor is put in a way that it is looking down. So whenever it is on the platform, it is sensing very small distance. Whenever it is on the platform, it is sensing very small distance. Let's assume maximum distance it is sensing is 4 centimeters. So normally when it is on the platform, it will sense 4 centimeters or less distance. So what we are saying is if distance is less than 4 centimeters, we will remove this, we'll bring it back again at the end. If the distance is less than 4 centimeter, keep moving forward. But if the distance is more than 4 centimeter, when will that happen? Whenever we reach the edge and our ultrasound sensor is looking down, and now it is not seeing the platform but it is seeing the ground, and the distance of the ground from ultrasound sensor is much more than 4 centimeters, which means now ultrasound sensor is sensing more than 4 centimeters, and that time it needs to turn. Maybe all those evasive actions, for example, you may decide to write v dot reverse 200 comma 200, and now you need to give a small delay, let's say 500 milliseconds. So it is coming back and then it is turning for, let's say, another 300. Now I have used delay, but I know that even if I don't sense during this time, doesn't matter, because I have returned back and then I'm turning. So there is no possibility that the vehicle will fall down from the platform. So even if it is brain dead during this time, it is not reading the sensor values, no problem. This is what we can write. Go forward when the distance is less than 4. If it is not less than 4, it is greater than 4, then take this evasive action. Again, we'll come back to this condition. We know our sensor gives unreliable values for distances more than 25 centimeters. So if my platform is elevated more than 25 centimeters, then our sensor is going to read value which is more than 25 centimeters when it goes on the edge, and then it may give value of 0.5, and 0.5 is less than 4, and our robot will think that since it is less than 4, let's go forward, and it will fall down. We don't want that to happen, so we want to add that condition. So if distance is greater than 0.5 and distance is less than 4, so go forward only if the distance is greater than 0.5 and distance is less than 4. So between the range 0.5 to 4, then only go forward. So if distance is less than 0.5, then take a evasive action. Distance is greater than 4, take a evasive action, because these are the conditions when we are at edge. Try this program, check what happens, fine tune it. Write your comments in the comment section in case you have doubts or in case your program does not work. Please understand, these are two common programs we do with ultrasound sensor: obstacle avoider and edge avoider. But this is not the end of it. Ultrasound sensor is used in many projects apart from these. These two programs are used to learn ultrasound sensor, but it can be used in many other cases. But the way of use does not change. You read the value, you store the value, you compare that value and decide what action you need to take. In our next video, we will come up with a new topic. Till then, bye bye.